Hola, Animigos, and welcome to Keyframers, the animated collaborative coding live stream where we bring imaginative user interfaces to life. I'm your host, Stephen Shaw, but you may know me as @Shashaw.
And I'm quarantined, aren't we all?
David Quarantined.
David Quarantined. That's how you pronounce my last name.
I always wondered.
I'm your host, David Khorshid, also known as @DavidKPiano.
And together we are coding compadres, animation amigos, Boolean buddies, and keyframe companions.
Yeah, so we're going to be creating an appropriately themed animation from scratch live today using HTML, CSS, and JavaScript.
That's right. This show is made possible by your support. You can pledge at patreon.com/keyframers or hit the like and subscribe buttons around the video. We do also have merch available, like the two shirts we're wearing. Yeah.
Totally coordinated that.
Yes. You can head on over to keyframe.rs/merch and pick up one of these cool shirts. Definitely check that out. And yeah,
and also feel free to chat or ask questions or anything in the comments or chat or wherever about this episode or previous episodes or anything. We're listening and watching.
We are happy to answer those questions. So if you're watching later on YouTube and are short on time, you can skip ahead to the summary of the animation at the end using the Keyflections link in the description below. And if you're joining us live, hey, glad to have you along with us. It's nice to see some friendly faces out there.
Yeah. So how's your quarantining going?
Not bad. We're basically set up for it anyway.
Right. That's one of the that's one of the good things about working from home is that it's already set up. So we're definitely good there.
Well, yeah, you're surviving all right.
I am. I have my hand sanitizer. So I think we're all good there.
Well, with the green screen.
Yeah, washing your hands is more effective though. So just be sure to do that.
Yeah. Well, we're not gonna be too much of a downer here. Pay attention to the news, stay safe, do all that
right.
Good
and
stuff.
Watch Keyframers if you're at home because what else are you gonna do?
It is a great time to learn some new skills. You should have a little bit more time on your hands.
Speaking of new skills, so last week we talked about XDate and I gave Shaw a short introduction to XDate in which we actually did a pretty deep dive. So that was pretty good. Yeah,
that episode is great. You can check that out on our YouTube channel, youtube.com/keyframers.
Mm-hmm.
The final animation ended up being really cool. I liked that.
Yeah. And by the way, if you ever find me in person, there's now XDate stickers. Yeah. Wow. These are the first two. It comes in black and white or white and black. The XDate logo fits really well with the Hex theme. So if you have other Hex stickers, they just fit together. So
that's beautiful.
Come find me. I have a limited run of them. So they cost me way too much money.
Yes, they get expensive.
I didn't know stickers were that expensive. It's like, hey, I want a few stickers. $100. I'm like, are you kidding me? Oh man.
We've already got the chat lighting up about the stickers. So
they are cool stickers.
Yeah. Awesome. So let's get into today's animation. Let's talk that through. Kind of fitting with the theme of the world at the moment. We wanted to work with an illustration of particles. If you let me see. Yeah, here I've got the link. I hope a lot of you have seen this wonderful Washington Post article, why outbreaks like coronavirus spread exponentially and how to flatten the curve. It's got so many great illustrations in it that are live simulations running in the page that give some really great information and really sell what they're talking about in the article. And so we're kind of covering this a little bit. There's So let's see. There's other people that have done similar animations to this, but this is where we're going to be covering today this kind of effect. And we'll be using these lines to illustrate the social distancing you need.
Yeah. I think that's commonly missed in these animations where you have two circles that if they collide with each other, then boom, you're infected. But that sort of misses the facts that you don't have to be right next to each other in order to get infected. It's like these particles could travel a distance of 6 feet. So we're going to try to illustrate that for you using this classic animation. This is one example of this connecting dots or communicating particles, whatever you want to call it, by Goji on CodePen.
Yes, I believe that's how you pronounce it. But yeah, it's a nice little animation, a great simulation. As you click through, you can add more particles, and whenever they're a certain distance away, they get connected by a line. And it's all actually using Canvas as well. So this is another great one to dive into. But we're actually going to be using Canvas, I think, for the first time on the stream.
Is it the first time? Okay, well so. Then, let's get into it.
So if you're unfamiliar, Canvas is basically a browser API for just drawing whatever you want. Oh, sorry, covering up your face here. Where is it? There we go. Canvas. So we're going to specifically be covering 2D Canvas, but Canvas is actually what powers WebGL and a lot of that as well. Those are all drawn onto a Canvas element. And so check out the MDN docs for that. There's a lot of great examples. But it's basically just a way for you to paint exact pixels in the browser. So you can start by creating an actual Canvas element, or you can create it programmatically in the JavaScript, document .create element Canvas, or whatever. But we've got it in the document here, and so we've got the canvas and the body, and what David's doing right now is setting the width equal to the body width.
Yeah, I just want to, so it should be by.inner width. Sorry.
Yeah.
The canvas width and height is correct, but basically this is a way of just making it full screen. And you'll typically see that, especially if you're creating a canvas dynamically, then you just set it to the body's inner width and inner height and not worry about it. Don't have to worry about, we have to make it with this many pixels, that many pixels, or setting it in the CSS. You could just do it in the JavaScript, just like that. What's wrong with inner width? I guess it's fine.
It wasn't working, so
still not working.
Yeah, it's working now.
Okay.
Over here.
Well, there we go. All right. So here is our canvas. Let's start drawing on.
All right. So in order to draw on the canvas, you have to get the context of the canvas. So we'll say const ctx is a common abbreviation for context. lcanvas.get context 2D. And that's kind of what I was alluding to earlier. We're using the 2D Canvas API. So
2D or not 2D?
Definitely 2D. We do not want to get into WebGL just yet.
That is the question.
Yes. So we have the context now, so we can do context. Let's see. Yeah, what is it? Fill rect 0, 0, 100, 100. CTX.
While you're doing that, I'm going to add a little class to this, just so we could draw a very simple particle. So, instructor, let's call this.
There we go.
That's why.
In the chat, asking if we're doing a dribble shot. No, we're not. We're not basing this off a specific dribble shot. We're creating an animation like this, though, particles and lines, and showing how to do that in Canvas. So I've got the context, and I'm setting the fill style. This is basically going to be the color we want, and then fill rect creates a filled in rectangle, at this X and Y coordinate, and then it makes it 100 pixels by 100 pixels. And so that's great. But in order to actually make, say, the square move, we need to create kind of an animation loop. So let's create a render function, and then we'll move our rectangle, or our square in here, and then we'll do requestAnimationFrame render so that it runs in a loop. And then we could do let x, we'll declare an x 0, and then we'll draw at x right there, and then start calling our render loop. And then if we do like x++, then our square will animate, right?
Whoa.
Kind of. Do you know what's going on, David?
Geez, are you forgetting to clear the canvas?
That's right. You have to clear the canvas every frame if you don't want the previous frame to remain.
I remember when I was first learning Canvas, that was like the silliest thing about it. I'm like,
it opens a lot of doors and helps you. It does help, but overall, it gives you some more options for what you can do with Canvas. But it is kind of a pain if you're doing something simple to remember to clear the canvas out, so that you get the.
Also, do you know what else is silly? The arc method. I just had to do this over here, this very small particle class that I created. So here's what I have over here. When you create a particle, I'm going to set the X and Y just in a random position in the screen. Doesn't matter, right? It's going to be somewhere within this canvas. And so I have a draw method on here too that draws itself. And so to do this, we're using arc. And I'm just using it to draw a circle. The first argument is the X. The second is the Y. So that's like the center of the circle. Then this is the radius. And I should really, you know what, just for my sanity. Oh, whoa.
Yeah. So,
are you getting some freezing happening?
Yeah, I think I froze it. Oh, no.
Oh, no.
Are you able to copy? Because I think I locked it in a loop.
Wait, let me see if I copied it. Okay, I copied it. Copy that. What did you do?
Try to refresh. I removed the X declaration before before I removed the reference to the X that renders every frame, and maxed out the browser, I think. So let's see if we can get back in here. Hold on. Technical difficulties. Yeah. Okay. Let me.
If you're in the chat, let us know how you're faring with this whole virus thing or whatever. While Shaw gets shut up again. Set up. Blah. Can't talk.
Okay. I think we're back. All right.
Oh, right.
Yes. So let me get the code back up here. There we go. Great. So one thing I'm going to do is change the behavior to not have an auto-updating preview, and we'll have our little run button so that we don't get into any render loop kind of issues.
That's probably a good idea. Is it the same collab link that you sent me?
Yeah. If you reopen that, it should be fine.
Okay. It's doing its thing.
Yeah, you may have to close that window entirely.
I did.
Oh, dear.
Okay.
All right. So what you're alluding to, so draw context arc, we're going to draw it at the X and Y position, and then 10 is the radius. Is that what you're?
Yeah, 10. I don't know. I just felt like 10. It is not wanting to open for me.
All right.
What did you do?
I did not do anything, David. Yeah, if you try to open that link again, it should come up, as long as you've closed out all other like CodePen links. So let's say.
All right, doing the nuclear option real quick.
All right.
Which is closing Chrome entirely and reopening it. You will be hearing from my lawyer for damages caused.
I expect nothing less.
Okay, let's. Yeah, this is one thing I love about Chrome is that you could just, any browser really does this nowadays, is that you get all of your windows back when you close it then reopen it. It's really, really handy.
W is not defined. Oh, with height. There we go. Hey guys. Yes, thank you, Vinny, for pointing that out. The W in the constructor should be width and height, and then white should be an actual string. Are you back in, David?
I am very close to being back in. I basically am back in, yeah.
Okay.
Don't worry about me.
Aye. Try. Why this is jamming up so much.
Did you break it again?
Yeah. I'm gonna wrap everything in a try catch, and that should hopefully prevent it from re-rendering.
Okay, yeah. I'm back in.
Okay, well I'm not, because it's frozen. So,
ooh, fun.
If you're able to copy everything at the moment.
Yeah.
Okay, there we go.
Well, just in an async sort of way, basically what we're going to be doing is we are going to create these classes, like a particle class. Actually, we're only creating one class. And these particles, we're going to generate like 100. And they're each going to have a position, and they're each going to have its own behavior. Like a particle might decide, I'm going to go this fast in this direction, and another particle might decide to go a little bit slower in a different direction. And, we might do some things where they bounce around the canvas or whatever. And all together, we are going to be measuring like just how far away these particles are from each other. That's a general idea.
Yes.
If Shaw gets back on.
I'm back in now. Hold on.
Awesome.
Catch E. And then we'll make sure that.
Okay. Particles have pushed new particle. Cool. So we have a particle, and you made radius a variable, which is cool.
Yeah, not specifically necessary, but nice. We could do the same with the fill style and all that, but not necessary.
In fact, I'm going to do this dot.
Copy and
Are you selecting it all?
I did for just a moment. Draw context is not. Oh, so this we just need CTX.
Yeah. Yeah.
Rerun. Okay, so we've got 3 random particles.
Cool.
Yeah.
Oh, I guess I had to click run. I'm like, I am not seeing them, but I will share your enthusiasm that they do exist. Okay. Yeah, I'm seeing 3 random particles. This is awesome. All right. So now you're going to make 100. Wow, that went from 0 to 100. That escalated quickly.
It very much did.
Wow.
We can at least test this out to see. That should work. I mean, yeah. All
right. So now what I'm going to do as well is I'm going to add a speed variable. This dot speed. We're just going to give it 10, whatever. So it's going to move at like 10 pixels every animation frame. And so we're not doing it like a per minute or whatever. It's just every single animation frame. It's going to move a specific number of pixels.
There we go.
So
nice. Okay, so the speed, you're going to do that, and one thing to check out is our episode on particles. We had a couple of those. Let's see, what is it? Sweet sliders. That was a good one. Yeah, you wanna check that one out, because we're gonna kind of get into the particle physics just a little bit, but not specifically too deep.
I'm gonna do something that you will not like.
Update.
This even work?
There. Where are you working? There you are. Awesome.
Look at my theta. That's better theta. All right, so we're going to choose a random angle. So these are all going to be moving at random angles, which is going to be great.
All right, so yeah, theta is just a direction. That's going to be a range from 0 to 360.
Fine, I'm going to call this direction angle. That's going to make more sense than theta. And so we're going to say, whenever each of these particles updates, we're going to, all right, so we need to keep track of the vector and the speed. So, and I will explain this right now, just, x is going to be,
I forget all this math off the top of my head.
Yeah, but you sort of need all of this math.
You do.
You do. Okay, so what's going to happen over here is that the vector, this is just going to, you remember our dx and dy? This is sort of like that, vector x and vector y. It's basically how fast is it going in and what direction is it going in. We're using that direction angle to help us out there. And so that vector angle, yep, Shaw has the right idea. So we're adding that vector x and vector y to it. And so, yeah, I guess we're updating and then drawing.
Yeah.
That works. Cool.
So now when I click run, we should have the particles all scatter off the screen. And 10 is probably way too fast. Yeah.
Yeah. But hey, that's awesome that that's working.
Yeah.
Yeah. That is pretty cool. Nailed it on the first try.
All right. So we probably want another function in here like check boundaries. And we can say if this dot x is greater than width, or this dot x is less than 0, this dot vector dot x times equals -1. And this is basically going to reverse the direction whenever it hits the edge of the canvas. This dot y, there we go. In theory, we gotta update the boundaries. This dot check boundaries. There we go. So now we've got a pretty realistic ball simulator.
Oh, that is super cool.
It's already already come together. All right.
Yeah. So now comes the linking time, and I'm going to make a link particles function. And what that's going to do is I'm too lazy to make a class and do all that right now. So all that's going to do is that's going to that's what's it going to do? Oh, okay. So we're going to take a particle and the other particles. And so it's going to draw a line from that particle to all of the other particles. So here's how that's going to happen. We could say for const p of other particles. So basically, we're taking a look at all of the other particles. And so we need the distance, first of all, from each of the particles. And so this is going to be mathy.
A squared plus b squared equals c squared.
Yeah. By the way, there is math.hypot that helps with this. I forget how it works, though. But that's essentially what we need. That mathy stuff. We're basically giving you a math lesson here.
Yeah, here's a
oh, that's just the distance. So x2 minus x1 and then y2 minus y1. So this is particle dot, did I call it x? Yeah, particle dot x minus
here, x distance. So what I've got here
of course you have that.
Is a simplification of it. Yeah, I think so. Yeah, particle. No, we just need to pass in. Let's see.
Oh, you're making it user friendly, aren't you?
P and then let's say constant particle, and then
well, this is a array called particle.
Oh, okay. So P. Particle P, and then if distance is greater than safe distance, continue.
Okay, I am adjusting the signature to your liking. Actually, that was pretty fun. So basically, I'm taking all those. All right, so distance particle P. So this is going to be the x1 and y1. This is going to be the x2 and y2. And so we have a safe distance. Okay, cool. And so let's set a line width equals 1. We'll just do that. Okay, you're doing it there. Well, actually, we do want to do it for. Actually, no. Yeah, I guess we could do it there.
It could be very. It could vary depending on the actual distance and such. For line width, I'm not. It's not too important. Draw ctx.stroke. Style equals white. Draw ctx dot.
Gotta begin the path, right?
Yeah, so we want to do begin path.
And then we're going to move to the first point.
Yes.
Which is that the particle dot x, particle dot y. Yep. And then we draw a line. So that's going to be that P. Yep. And draw context dot. We just stroke.
Not. Oh, yeah. We don't want that, but we do want to stroke. And then next time when we begin path, it'll close that, reset it. All right. So.
Oh, now we actually have to put it in the rendering thing.
Right. So we'll go down here. Let's save really quick, and we'll do link particles. Right. Oh, we have to do it for each individual particle. Yeah.
Exactly. Okay. Yep.
Yeah. So
it is an O of n squared calculation.
Particle. We'll do particles. and then CTX as the context to draw on. All right, so let's see how badly we've broken it. Okay, we've got an error. Cannot access distance before initialization. Oh, const D. Const D. There we go. That should help. There we go. Whoa. All right, so we're linking every particle.
Every particle to every other particle.
Okay,
and this is cool. It is generative and it's awesome, but yeah, we probably all right. So we have our safe distance here. Maybe we want to.
I think our distance calculation is off.
Probably.
But we are linking the particles, which is nice. Let's see, stroke style. Let's do GBA.
Well, what is our safe distance?
30 right now. So
Okay.
that should be much closer. I want to check the D value. Let me just turn off the re-rendering. So we'll just render one frame, and we can console.log the distance to check if it's greater than. Console.log D particle P. All right, this is.
Yay for console.
Let's open up debug mode in a new window.
Wow. So this is like this simulation right now is like if anyone got infected from anywhere. Like if it was a super infectious virus, then
yes, that traveled at the speed of light.
Mm-hmm.
Okay, so D is only 20 on that one, and 20. Okay, it's just consistently coming back as 20. I'm not sure. Let's just try simplifying here. Oh, I see what you did. That's not right.
Yeah, I changed it because you wanted you want to pass in just the particles.
Yes, and I've got that set up with this if non or is non set up. So that was
okay.
Yeah.
Well,
Save, run. Now
that's some polymorphism you got going on there.
Okay, there we go. All right. So now we can re-render. We'll probably want to update our safe distance to be a little longer.
You have the animation pause?
No.
It's not yeah, it's working. Whoa, hey, there we go. Look, when they're close together, they get brighter. And I programmed it as such.
Oh yeah, yeah. So we just need to update the safe distance to be a little bit further away.
Yeah,
maybe like 80. Let's try that.
This is so neat.
Nice. Yeah.
Okay.
Like
all right. So, wow, we did that pretty quickly.
Yeah.
So
you've been watching Keyframers. Thanks for tuning in.
No, you can't just assume everyone's healthy. Speaking of which, in the particle, I added two little things here. I added a status variable. Right now it's healthy. It assumes everyone's healthy. And then I have an infect variable so that other particles can infect other particles. And so this just says this dot status is infected. And so when we update, we could say if this dot status is infected, or well, you're adding an enum like a proper software engineer. So this is dot infected. Then we're going to say this dot color equals green. I don't know. We'll pick better colors later, but right now we're just going to make it green. So we have, yep. All right. So now how do they get infected? In link particles, and that's when we're determining the distance. Gas equals 1 over d minus safe distance. What's a good distance for us to infect the other particle?
Const infected distance would be like 10. Maybe 10? We'll go 20.
Okay, so I'm going to put here infects other particle. So basically, if it's close enough to another particle, I'm going to say if d is less than what, 10? Or well, whatever you want to change it to. Aha! You are preventing me from hard coding, preventing me from making a mistake. And all right, so if the distance is small enough, and if the main particle, so if p dot status equals statuses dot infected, and so if one particle is infected, then this particle dot status is going to be, or we're going to infect it. So infect. Does that work?
I'm not sure. Getting some lag here, so let me just make sure.
Yeah. Oh yeah, I'm getting some serious lag too.
Particle dot infect. Do we actually have that? Okay, we do have that method. Stances, this dot color. Oh, I don't think we're. Are we using? Yeah.
I'm lagging.
Let's see.
Yep, I'm frozen.
Oh, geez.
Infected.
Oh no. Well, I'm saving everything.
Oh, now I am healthy again. Wait, no.
So particle, yeah. So p dot status and d.
Because that infects that particle.
Yes.
Okay. So, man, I'm going to reload. Famous last words, but I'm going to reload.
Let's do.
Let's
do these a little bit bigger because that's probably not showing up well. Dan in the chat asking about this app. This is Dash app. It's a great way to look up documentation on the go. I do recommend it. Why is that going so slow?
I don't know. My thing just crashed. So, page unresponsive. Great. Okay. Try this again. All right. Are we getting some infection happening?
Maybe.
Let's find out, because when it infects, it should change. Well, yeah, it's going to change the color to green. In fact, I'll just put that here just to make things a little bit cleaner. Yeah.
So instead of using RGBA, I'm now using global alpha. The infect just does not seem to be. Oh, we don't have any. We don't have any that are infected. We need to.
Oh, right, yeah. Aha. So no. So it is working. We just have a completely healthy population. But let's infect one. So in this status, you know what? We're gonna leave it to chance. So math.random is less than what? 0.3. Let's infect a lot of people right now. Infected, or well, actually, everyone starts off healthy, of course, right? And then we're going to say if math.random is less than 0.5, then guess what? We're infected. Let's try that.
That should infect a lot.
Oh, wow. Okay, we are getting lots of infections.
Yeah, we need to slow that down a little bit. There we go.
Can't just do that. You're not the CDC. Okay, wow. Okay, things are getting infected, but after a while, things get healthier. So we could also, in infect, we could, actually, we could say, and this is why a state machine is good, because right now I'm going to be doing a little bit of defensive programming that you would not need to do if you had a state machine. So I'm just saying, if this dot status is already statuses dot infected, then return. Like you can't get infected more than once, right?
Right.
So now we're going to set timeout, because after a while we want to become uninfected. So we're just going to say, or actually,
recovered.
Yeah, I was going to say immunize, but recover works too. So after how many seconds? Like 1, 2. So we're going to say this dot status equals statuses dot, what do you have, recovered? Yes, covered. And we're going to say this dot color is, I don't know. We'll deal with the colors later. All right, so after 2 seconds, they should go back to being healthy. I think that's a general idea.
Yeah.
And they do.
Here.
Sweet.
Hot pink. But they can get infected again, apparently.
Yeah, all right, so, and this is why a state machine is good. So,
well, in our
equals status is, I might just turn this into a proper state machine, but yeah, see, that's why we already ran into edge cases of not using a state machine. So yeah, Shaw's right. Once they get infected and they recover, they can no longer get infected again, which is exactly right. So,
but we get a perfectly healthy population.
Yeah, after a while. Wow, they actually, yeah, maybe we should up the rate or something like
so
that.
I increased the time to heal.
Yeah. So yeah, we're getting a lot recovered, but still a lot of, you know. I mean, that's cool. It shows just how many people recovered. I don't really want to model dying because that's pretty sad, but yeah.
You know, we could also do here if particle.status equals statuses infected, then it's linked. Otherwise, we don't even render the lines for them. Particle.status distance is not defined. What? Are you updating something?
Yes, I am.
Oh, okay. Oh no. You froze me, David.
Did I? I'm sorry.
I think so.
Maybe there's a memory leak somewhere.
Yeah, I think so. Oh, I know what it is. Oh, no.
What is it?
I was thinking it was the arc, but no. I don't know.
Let's see, for Vera, I'm trying to see if there's any potential memory leaks. I don't really see any.
So let's do that. Let's do 20. And let's
Are you back in?
yeah, it seems to be working now.
Okay, cool. So yeah, I added a where'd it go? There's safe distance, infected distance, recovery time. Aha, I have the stay at home variable. So basically this is just the chances of someone staying at home. I'll make it even lower.
Nice.
Yeah. So in fact, that should be 0 and then 1. Okay. And basically, if you're staying at home, your speed is 0. That's sort of how that works. And I also upped the, or unless you change it, the recovery time is 7 seconds, which is great. We have an infection rate. What is that? Oh, just 0.1. Let's, you know what? In this day and age, there's a lot more people infected than we think, so I'm just going to bump that to 0.2. Okay, so let's say we have a lot of people infected, right? Wait a minute, are we still infecting people?
Yeah, that doesn't seem to be working. Infect. So it's this dot status. It's infected or recovered.
Maybe it's the infected distance thing.
No, I adjusted that to bump it up even more. If it's a safe distance, continue.
Yeah, something changed because I'm seeing some of them. They should definitely be.
I think I see what it is. Yeah,
infected.
There it is.
What happened?
So one thing I did was eliminated the lines, unless they're infected.
Yeah, but you still need to go through the loop to check.
Well, so I had to do it reversed. So if the particle's status is infected, then it needs to infect the other particle there. Yeah.
Gotcha.
Yeah. So the lines are drawn based on this safe distance variable, and then nobody seems to be recovering.
People are recovering.
Okay. It's just kind of grinding to a halt on mine. I don't know why. So there we go. And just the more lines there are, the slower it goes. But I mean, this.
Yeah. Wondering why that is, but regardless.
Yeah. Let's simplify our distance here.
Wow, that's a lot of lines.
Yeah, it gets.
So, Mitch Abenzensek says, I guess the lines are drawn based on the distance between the dots. Yeah, that's exactly right. So, what we're doing is for every dot, we check, all of the other dots, and we see, how far we are from them. And if it's below a certain threshold, then we go ahead and draw that line. Now, you computer science nerds out there will be like, okay, that's an O of n squared operation. That could be made more efficient. Yes, absolutely right, but we're not going to do that. In fact, if you know the way to make it more efficient, then please let us know. I know you have to keep just keep in memory which ones have already been visited, etc. And then there's other techniques commonly used in game programming, like the quadrants thing, where you just say, we know that this is in this quadrant, so only check these particles that are in this specific quadrant and that specific quadrant. And so there is that technique too.
Think it's so hard to tell when it's frozen or broken. There we go. Nice. All right. Well, this is at a pretty good spot.
Yeah. Yeah, and it really illustrates the just state of things.
It really means you need to stay at home, keep your
Yep.
distance, and that will help everybody out. Fill color there. We can adjust some of the other stuff later. Yeah, I think this is a good spot.
Yeah, for sure.
Shall we keyflect?
Let's keyflect.
All right. We're now moving into Keyflections, a quick review of the techniques used to build this animation. If you have any questions, ask us in the chat or leave a comment below, and we'll be happy to answer.
Mm-hmm. I lost my screen. But yeah, if you've enjoyed watching us so far, you can follow and subscribe here on YouTube or pledge at patreon.com/keyframers. Links are available below.
Yes. So today we wanted to cover some canvas drawing techniques, and this is a pretty classic animation that you'll see as like backgrounds on websites. I think I've used that before, and it showcases a few different things. Number one, just drawing with canvas, which we've never really covered before, and then two, vector physics. Very basic and very simple, and a little bit of just calculation. I don't know what. I guess that falls under vector physics there, but yeah. So overall, we've got a canvas element, and then some minimal styles to just get that canvas full screen and get everything in place. And we're selecting the canvas, and then for canvas to draw to it, you need to select the context. We're using 2D canvas here for this animation, and then we're setting the canvas to the full width and height of the body, and then down below we've got our particle class. You want to walk us through that real quick?
Yeah, sure. So you could think of each of these individual particles as an entity. And each one of them has a certain number of characteristics. First, we have a random position on the screen, and just basic stuff like radius, color, and speed, where here's the interesting thing. The speed is a random number between 0 and 1, where if it's less than the stay-at-home threshold, which is the probability that someone will stay at home, then they don't move at all. Otherwise, they move at a constant rate. And we have this direction angle, which is sort of randomized so that each particle's movement is random. And we use this vector to determine basically the change in x and y on that direction angle. And that's just a trigonometric way of figuring that out. Of course, you could just do math.random for x and y, whatever you want to do. And of course, we have this dot status because we want to measure whether each one is healthy, infected, or recovered. And so the behavior here is, you have a 25% chance of getting infected, I guess right now. And so if another particle infects you, then and you are otherwise healthy, then your color changes to green, your status becomes infected, and after a short recovery time, or hopefully short, right? I think it's about 2 weeks at this point, then you recover. And when you recover, you have a color of hot pink, and now you're in the status of recovered. And so we have two main functions over here, which is draw, which actually draws the particle, and we have update, which updates the position of the particle. And check boundaries is just to check that it's not past the screen. We want it to stay within the bounds because let's say some nation closed its borders or something, and so it's just going to bounce around the bounds of our window.
That's right. And so we're creating a, let's see, particle count, update that there. So we've got an array of all of these particles that we're just generating with a for loop, and we're just creating the new particles in there. And then we have a render function that is going to is going to run every animation frame via requestAnimationFrame. First, we have to clear out the canvas, because if we don't, the canvas is just going to continue to draw on top of itself. Let's see that really quick, because that'll be a... that's pretty cool. That is... I like that effect. But if we don't want that, we can clear out the entire canvas, each frame, clear rect, and then we loop through each particle to update its position, draw it to the canvas, and then link it to the others. We could probably move the linking up above so the particle stays on top, and yeah, that should look pretty good. Yeah, so that's the linking particles. I'll cover that real quick. So this function loops through each particle for each particle.
A lot.
Yeah, but I mean there are other approaches to do it, but this is
simplest way.
Yeah. So basically, for each particle, we're checking its distance from other particles. So D, if D is under the safe distance, right now that's around 130, then we just move on and we don't worry about it. Otherwise, if they're in the infected distance, then we infect, and the rest is to draw a line in between that and the other particles there. So that is what renders all these nice little lines.
Mm-hmm. Yep, and there's not much in the way of CSS or HTML, so very JavaScript heavy.
Yeah, well, with Canvas, there really isn't another way to do it other than with JavaScript. So it is a little bit more efficient than if we were doing all of these particles as like individual elements. We'd still have like a lot of JavaScript to manage all of that, and then the browser would have to kick in rendering all of those individually. Whereas with Canvas, it can just draw all of that to one DOM element pretty efficiently. So that's one of the advantages of Canvas. There is particle effects like this in particular are much more efficient than their DOM-based counterparts. Yeah.
Right.
All right. Well, yeah, I think that's pretty much it. So play around with these variables and see what else you can come up with. If you try out Canvas, please be sure to share us what you've made. We'd love to see that. But for now, you've been watching Keyframers. If you've enjoyed this episode and would like to see more from David and I, you can support us at patreon.com/Keyframers. You can visit our merch store for some sweet Keyframers merch at keyframe.rs/merch, or you can like and subscribe at youtube.com/Keyframers.
And also, we accept submissions for future episodes. So if you want something specific that you want to see next week, tweet at Keyframers or any of us to see any of these animations that you want to see made. And you could also present questions or challenges that we will try to answer on the air. So please share this video and demo across all of your social platforms.
Yes. Well, that's all we have for you today. Thank you so much for joining us. Until next time, adios, Animigos.
Stay at home.
Stay at home and stay well.